What class is this? 470 to 250. For some of you, it might not make a difference.
I don't want to do
There was a couple of answers on the exam in here that we could have just thrown into the 250 exam and you would have earned the same number of points. It just wouldn't have made a difference.
If you had the choice to jump into 250 right now, I'd be like, no way.
And don't you hate it too when you show up and you see like the solution to the exams? You're like, that was all it was? Yeah. Doesn't that suck? Man.
That's why you do it, right?
But I advertise that. I like human misery. I mean, it's a hobby.
On the last question, for some reason, I read it as, it clearly said positive integers, but I read it as even integers.
Okay.
So I did the answer with even integers, and then I read it when I was leaving, because I had the sheet with me still.
Yeah.
And I was like, yeah, I'm an idiot.
So you're illiterate.
Yeah, pretty much. Oh.
That makes sense. You just got what illiterate means?
No, I just got the positive.
Because, we do have an English as a second language program. Oh, yeah. At the very least, you can say this class is fun. It's hard, but it's fun, right? Well, that's because of me. I mean, the class material itself is... You could put me in front of an English class, it would be entertaining. I'm not going to teach you a whole lot of English. I can do this stuff. When in doubt, add commas, right, in English. Okay, so we've been working off a kind of an expanded grammar here, a let-based language, where we had our wrapper for our program, and we have not had an assignment on this yet, right? We've introduced it like 1.5 times, but haven't actually done an assignment related to this guy. Oh, we wrote a parser, just one way, right? We wrote a parser. So we've done the lead up to working with things. Okay, so let me push forward here a little bit. We started talking about types. We started talking about environments. Specifying behaviors of expressions. So now we start moving towards, and let's just give you some background on this. And we've already seen this before, but let's kind of get a slide for, let's call it interpreter process. So number 1, we parse. Number 2, we apply input to parsed logic. All right, so your book uses this thing, a lot of times it's called apply something, apply expression, or apply, we'll probably write something called apply program. And what it's saying is here's a program, and this is a parsed program, okay? And we want to apply that program to these inputs. So it's kind of like passing it in as a input to the function, right? So we want to apply it to that. So your book will use that name apply pretty often. And all this is done in the context of an environment. We can certainly see that as we go farther down the line and our languages start getting more complex, where we start defining variables and having scopes. We already have this lambda calculus expression that we're used to, where we have variables that get bound, right, and then get bound to potentially a value of our expression. So those things need to then get entered into a variable expression, or an environment, variable environment, that we can then pass around, because the current scope, the current value of a particular variable is going to be necessary if we are applying a program, right? If we're executing a program and you need to have the value of A, you're going to need that variable environment in its current state. There. And because we know about scopes, how you might have a function up here where one scope exists, you have a function down here where another scope exists, those might be 2 different versions of that environment, right? So when we call apply program on the car of the expression, passing an environment, and then we call apply environment on the catter of the thing, passing it an extended environment with a new variable, those are 2 kind of conflicting environments that each of those subprograms get executed within. Does that make some sense? So we're going to be passing this environment around, and the environment is going to be whatever it is at the time we need it. not necessarily this global pointer that is, this one environment that has all the variables that are ever added to it, because we do have scopes that are going to be local definition scopes. So if we come down here, so this guy's starting to get into types and return values. So this thinks about, so if we have a constant expression, let me quickly look at my grammar up here just to see what. Okay, so we have a number which parses to a const expression. So we have constants that are going to be numbers. We have a diff expression. We have a zero expression. We have an if expression. We have a var expression. So that's a variable that should resolve to a value with an environment when we actually go to apply that. And then we have our let expressions, which should give us an extended environment, right? With a let should come a new environment that has more stuff in it. So if I pass in initially the empty environment, and then I am processing, I'm applying a let, that let is going to extend the environment with whatever new variable. In this case, a let only allows you to have a single name value pair. So we'll extend our environment with a brand new identifier, just a single one. So our version of a let here doesn't take a list of parameters, it takes just one dude. So with a single name value pair, and its value will be apply expression on the expression of it. So this guy's going to have to get applied in the current scope with the current environment. Okay. So I guess let's look at it from this perspective then. Since we rewrote it anyways, we wrote our parser to parse this guy a little bit different than this, because we did a list-based language instead of the symbol-based language here. Like, we don't have a minus expression comma expression. We have a parenthesis minus expression space expression. Ours looks like that. And let me open up this guy. Did we already write? My list of divisors. This was the solution to the homework, right? Did I post that on Slack already? That's what I meant, midterm. Doesn't look like it. Let me put that up there. Okay, so that guy's up there, so I can delete it from here. All right, so we already have our parse program written from last time. So parse program just creates a wrapper where we have a list that has a program in it, and then the rest of it's going to be parse expression of that dude, and then our parse expression is going to be, this was the solution to the last homework assignment, right? So we gave an example here. If we're dealing with an if, parse something like this, and we get a where's my program start? Here's a program, here's a list, if expression, here's a const expression for that first part, here's a var expression for that next part, and then we have a zero expression. So this is what happens if it's true, this is what happens if it's false, even though we technically don't have booleans at this point. So this if is not really a real if, it just looks like an if at this point. So here's what we would call our Boolean expression, our test. Here is what happens if that guy was true in our world. Here's what happens when that guy is false. All right, so now if we're going to write apply program for this guy, okay, apply program is going to take in it's going to take in a parsed program, right? And it's going to then apply that program starting off with, and I'll ask this in a second, so let's just write our lambda here. So let's call this a parsed program that'll really let us know that this guy has already been parsed. That's important. Otherwise, we need to do the parsing and the applying at the same time, and that will make things very, very complex as soon as a language gets even mediumly difficult or mediumly large. So this will take in the parsed version of a program, and we're going to do something with it. Well, we know that a program is actually just a wrapper, right? It's a wrapper for an expression. So let me actually just stop this guy for a second right here so I can go and write the next thing. So really what we need to do is we need to apply the expression, right? So we're going to have apply expression, and this guy will be a lambda, and this guy's going to take in a parsed expression as a parameter. What else will we take in? Let me add one thing up here. So we have our parsed program. Actually, this will be good enough for right now. So what else does an apply expression need to take? When you write a program, so we have a Java program or something like that, you don't send inputs into the program. The program asks for inputs, right? We might have inputs for aspects of the program, like when we call a function or something like that. So we don't necessarily have direct inputs here. But what variables do we have access to when a program first starts? What things that we did not write do we have access to? So let's just talk about Java for a second. I'm on line 1 of my Java program. What are some things I can write on line 1 of my Java program? What are things I could print out? Let's go that route. What are things I could print out on line 1 of my Java program? Well, hello world is one of them, right? Okay, so string literals. We can write any string literal we want. We can print that out. What about numbers? Can we print out numbers? So Java already knows about all the constants. Can we print out any Unicode character? Java's good with those. What else? Do we have some objects that are already available to us? So we have these like external libraries, right? So when a Java program first starts, even though we really haven't done anything ourselves, we really have kind of an environment of stuff available to us without us doing anything, right? Just by the invisible import java.lang thing at the top. Just by that stuff, we have things available to us, right? Now, our language here is not as complex as Java yet. So what do we have available to us when we first start writing our program? Where can I look? If I go to print something out in my program, even though we don't have a print, a printability at this point, if I did have a printability, where do I look for values that I'm allowed to print? It's not in my variable environment, right? And what does my variable environment look like when my program first starts? How many variables do I have in there? 0. So it looks like a nice empty list, right? But at some point, we need to get the ball rolling. So what this apply expression is going to take is it's going to take in an environment. The environment in which we are applying this parsed expression. Every single time we call apply expression, we're going to have to tell it what environment, what scope do you live in, and here's what's available to you. He might extend this environment within this copy of apply expression. But initially, this is what he has to work with. All right, so I'm going to just close that off here for a second. Now, when we look at our parsed program, so our parsed program looks like this. So really, it's the car of this guy is a program. The catter is our parsed expression, correct? So apply program should do what? What should apply program call? Okay, apply expression passing it what? So apply expression. Yep. So apply expression, and we're going to pass it the CADR of parsed program as well as an empty list. Now, maybe more correctly, do we still have our variable environment up here somewhere? Yeah, we do. So maybe more correctly, we could pass it an empty env, which actually we wrote as a bunch of constructors here. So we have empty env, we have extend env, which takes in a single var val. So let's use what we have. All right, so we're going to actually pass that guy an empty env, so it won't be the empty list, it'll actually be the list containing the string empty env. Make sense? So rather than just hard coding empty list, we're going to actually pass in empty env, which is our constructor for our empty environment. And just to prove that we're passing in the right thing, if we come in here and we just have this guy boil down to the environment, we should then see what that environment looks like. So we'll do a define p1. Actually, we already have parse program 1. pp1 would probably sound funny. But parsed p1. So I could see who's paying attention based on who laughed. All right, so parsed p1. And we'll go ahead and call apply program, passing it parsed p1. And all this guy is going to do is it's going to unpack the program aspect of this, grabbing the expression that lives inside of that program, because that's what a program is, an expression, right? So grabbing that top level expression, and then also passing along the empty environment, which right now we're just going to print out just to make sure that we're truly getting that empty environment. So let's run this real quick, because we're going to have to remind ourselves a little bit about, oh, I'm still printing out a bunch of stuff ahead of time, but here's my empty environment down here. All right, let me go and parse expression, apply math expression. Here, I think it's, let's just put a comment before that guy. Is that the only extra thing it's printing out? Nope. Listo bindings. All right, I think that's it. Yeah. All right, I just went through and commented out all the places we were testing past programs, so our output is a little cleaner here. Okay, so now let's look at a couple of our sample things and decide how apply programs should work for these things. So for instance, if we have a number, we'll start with the easy one, right? So we can have a program that literally is a const expression. It's just a number. So what would that program look like? We came up here and our program P1 was just a 5. Is that a legitimate program? All right. And if we come in here real quick, if I do parsed expression, that guy should look like a const expression. So there's my const expression 5. Parser still works. Okay. So now if I'm applying that program, so now we got to start throwing our cons in there, because that's what our pattern is for writing our parsers right now. So we have a cond, And the first thing we're going to be looking for is whether or not we know the thing that we have is going to be a list. That's the beauty of having a pre-parsed expression, right? So I could say if EQV car parsed expression, expression, did it. The car of that guy is equivalent to const exp. It's equivalent to our constant expression. What do? How do I evaluate a constant expression? Do I need to do any variable resolution? Do I need to call apply expression again? Nothing special, right? I just boil down to the number, the value. So I need to extract the value out of this, and that's going to be the CADR, C-A-D-R. So CADR of parsed expression. And there's our 5. So far, so good. No big deal. All right. So that's this person here. What about a diff expression? So a diff expression, is the car is going to be diff expression. So EQV car parsed expression, if it's a diff expression, it's one of those dudes, okay, which looks like, well, looks similar to this. Our diff expression is a list it's gonna say diff expression, then a minus sign, and then 2 expressions. All right, so if we look up here, let's just change this guy to a diff expression. So minus 5, 4, something like that. That would be an example of a diff expression. Okay. And just for the sake of our argument here real quick, if the car of that is that, I'm just going to show you the parsed expression. That way you can see what it looks like, so we can decide how to piece things out. Okay, pretty important thing we're doing here, because especially since there's been some time since we wrote our parser. Okay, I'm just saying, look, I'm going down my list. I'm saying, okay, here's a const expression. We just handled that, right? But we looked at what my parsed version of that looked like first. And once I saw that, I saw, oh, it's a 2 list. Okay, the first part I don't care about. That was just the part that marked it up. But second part's what I want. That's a CADR. But go ahead and print it out so you see it. Then you can easily say, I need this piece and I need this piece, and what do I do with them? Okay? So let's go ahead and look at what that guy looks like if it happens to be a diff expression. We know that the dude we wrote right here should parse into a diff expression. Now we're just going to remind ourselves what that parsed version looks like. Make sense? We could also just print out P1 up here if that made us happier. You know, you could just come up here and say P1, and you always see what the, actually, you won't see it there. You want to look at parsed P1, formerly PP1. We should have kept that variable name. Just like every 6 minutes, we can just get a little laugh, right? All right, so there's our list. So we've, minus program. Why does this still have a const expression in it? Oh, thank you. There we go. Looks better now. All right. Yeah, because I didn't quote it there, this is a function that's built into Scheme, the minus function. It took 5 minus 4, gave me a 1, so this guy boiled down to the number 1, so we once again had a const expression, right? So if I don't want it to actually execute that, I want it to be my language, we're going to have to be careful of that. That's why I did it on purpose, right? Okay, we're going to have to be careful of that. We don't want Scheme to do too much of the work for us. Well, maybe you do, but you know, we're writing our own Scheme interpreter inside of Scheme. Why use the one that's already built? There's no fun in that. What's up? Yeah, cool, cool kids write their own stuff. It's true. All right. What was I doing? Oh, look at this. So here's our diff expression. This is what that guy, so this was my output from right here, where I just spit it back out. So that proved that we got into that production of the cond. So we know the diff expression is there. We know that, so what does it mean to be a diff expression? We're going to do some subtraction, right? And what are we subtracting? We're subtracting the result of that guy and the result of this guy. How do I get the result of this dude? Somebody who usually doesn't answer. The guy I have highlighted there. How do I get the result of that? I think we could self-segregate on who's the ones who usually answer and who doesn't. Just like ask yourself inside your head, do I usually answer? If the answer's no, then I invite you to, to answer the question. We just had an example of this a few minutes ago. How do I get the answer of this guy? And who boils him down to the 5? So you wanna, didn't we already solve the problem? Don't I already have a nice little blender I can throw this guy into that will give me the 5? What's that blender called? Apply expression. All right, so I need to call apply expression on this dude. I also need to call apply expression on this dude. Okay, so how do I call apply expression on this guy? Let's just start with just that piece. How do I call apply expression on him? How do I get that one piece? That's the CADR. You already said that, right? The catter. All right. So help me call apply expression on that. Apply expression. You said you want the catter, CADR, of our parsed expression. Are we done? Look at apply expression. What does apply expression take as parameters? Environment. What do I pass it? Yep, we pass. It's an important thing. We are currently living in an environment. All we can do is hand that guy to the next dude. Here's everything we know about right now. So we're going to hand ENV, the guy we already have, the guy that came into this call to apply expression. We'll go ahead and pass that on to apply expression for that first expression there. Make sense? Now, what am I going to, so this guy's going to ultimately boil down to a value. We happen to know in this particular case that the value it boils down to is going to be a number, right? Because we know what we wrote. So we just passed in the const expression for the 5. It'll spit back a 5 to us. And then I also want to pass in the apply expression for the other guy, the other expression. Okay, how do I get that one? Help me call that guy. So just write it again after this. Let me actually, well, I'll just kick it down a line right here. So we're going to call apply expression. Now I want the second expression. How do I get the second expression? The CADDR, carve the cutter, CADDR. So that's getting this piece of that guy, right? That's the parsed expression. So CADDR of parsed expression, passing along that environment. So I'm going to get 2 answers out of those, right? Parsed expression is going to do its magic on the first thing. Apply expression will do its magic on the first thing. Apply expression will do its magic on the second thing. And because I'm in a diff expression, what do I do with those? Subtract them. So this guy minus this guy. So I'm going to call the subtraction function, passing it the result of this and the result of this. Make sense? So in this case, we should get the answer 1. Because 5 minus 4 is 1, but we didn't just let scheme do it. We let scheme, we let our interpreter go through and interpret the parsed program. So there's our 1. So this parsed program boils down to this answer. We change the 4 to a 7 or something like that. We should now get a -2. So it works for other things, right?
Is there anywhere in this where we manipulate the environment?
Well, we're getting there. Well, actually, here, how about we have you answer your own question? Here's our program right here. So tell me, out of these, so hold on, just as a review, since it was missed so often on the exam, what's this whole thing here called? That's a grammar. What's each of these individual steps called? It does start with a P. It's not a procedure. I've already said it once today. Production. These are productions. Okay. So these are productions within the grammar. So which of these productions, by you looking at them, do you think would cause our environment to change? I'll give you a hint. It's just one of them. Somebody who usually doesn't answer. Well, keep up the game. Because I'm going to give you a hint, by the way. If you pay good attention in class and you actually get involved and answer questions, you're going to actually start understanding this stuff better. Go ahead. Don't answer this wrong, dude.
Never mind.
No, go ahead. So, no, go ahead.
The identifier is bar.
No, but close. That would be the other side of the question. If it's a var, then I'm going to have to use the environment to get the value. But he's not going to be the one who changes the environment. Okay? If I'm on he's talking about this guy here. If I'm on a var expression, I'll have to then consult the environment and say, what is the value of this variable name? Which of these productions adds a new variable name to the environment? Who said that? Do you answer? Yeah, you're fine. You're very quiet for somebody who's not quiet sometimes. It's very weird.
I'm on and off,
So
I have
that's
my moments.
really?
Yeah.
It's like, I was I was creeping on you. You were sitting down in the what's it called, the nest? Not the nest. Landing.
Landing?
Yeah, you had your headphones on and stuff. I was just standing right over you, just kind
Really?
of. It was like about an hour ago, 45 minutes ago.
Oh, that's creepy. Wow.
You didn't even know I was there, did you?
Wow.
I mean, I was standing like right behind you, I was like breathing on you.
Probably would freak me out. I was watching Stranger Things. I was on edge.
You're in Stranger Things 2, second
Yeah,
season?
Yeah.
Oh, let me tell you what happens, dude. Which episode are you on?
5.
Okay.
Right where they're trying to find.
Don't say it. See, that's what I'm going to threaten you. How many of you are watching Stranger Things 2 in here?
Already watched.
Okay, but you're in the process of watching. That's my threat. Okay. Pay attention and participate in class, or I'm going to start dropping spoilers. Because, man, the ending.
Something like 6 cents that's already been spoiled.
Well, that would be less of a threat.
Exactly.
Yeah, that's why I'm doing a more appropriate threat. All right, you said the let expression. All right, okay. Why? Wait, first of all, what is a let expression?
It allows you to find variable.
It creates a scope. It's our current means of creating a local scope. So one would think that our let here should probably work like that, right? So I'm going to be expanding my current variable environment with a brand new identifier and expression. Make sense? And that's going to extend my environment so that future thing, so for instance, here's a let. If I say let a equals 5 in here, or for us it'll be parenthesis let a 5, and then the last part of it would be the body of that let, which will be the expression. And let's say this guy was just a, which would be a var expression, correct? So if I wrote the here, let's just write it real quick so you can kind of see what it looks like. So if I say let a be 5, and then the body of my expression would be a. We did write the let up here, right? So list do I have the... Yeah, that should be good. Oh, I didn't close the guy here. And for right now, well, we're fine. It's not going to be able to process the thing yet. So here's our let expression that has A, and A is equal to this expression. It's a constant expression. And this is the body. The body is var expression A. So if this is my parsed program, what should apply program, or therefore apply expression, return for this guy? What should this boil down to? Just a 5, right? I mean, this program is equivalent to us in Java saying this. Int A is equal to 5. System.out.println A. That's what that program does. We just happen to do it inside of a let because that's the only way we can create an extended scope at this point. Okay? Define a variable. A is equal to 5. Then boil down to that value. Make sense? Okay. So let's keep writing a few things. For your homework assignment, make var expression and let expression work. So that is to say, this guy right here should function. I shouldn't get all question results were false. What does that mean? That means that I ran out of cons, right? I don't have the guy that looks for a let expression at this point. Similarly, I also don't have the guy that looks for a var expression. Okay, so you're going to need to add both of those to our language for our homework assignment. Does that make sense? All right, so let's look at these other ones just for a few minutes, if we have a few minutes left. So we wrote diff expression. Not too bad. What about a zero expression? So zero expression would have been parenthesis, 0, and then some expression, right? So when I get a zero expression, so if I come up here, and I say 0, 5, something like that, this is what that parsed expression looks like. It's a 0 question mark exp. That's how we parsed it. And then it has a const expression 5 in it. What do I do with that const expression? So I'm looking for a car that looks like this. So if we're just going to write this guy real quick. EQV, car, parsed expression. That guy is equal to a 0 expression like that. That's the kind of dude I'm looking for. I'm going to be returning a 0, or true or false, right? That's the question mark usually tells us it's the predicate. All right, so I'm testing whatever it is against what? I'm trying to see if what is equal to 0. This guy. So how do I get this guy? Okay, but how do I extract that guy? You're right. I do need to call apply expression on that. Is that the car or the cooter? Yeah. Okay, because I'm only working with this piece of it, right? That's my expression that was passed into apply expression. So I'm going to call car, well, I'm sorry, let's call apply expression, the car of the cooter of parsed expression, along with same environment, along with my environment. And that guy's going to boil down to some value, right? We happen to know based on our example, it's going to boil down to a 5. Now, what should I be checking here? If it's equal to 0. All right, so I want to return true if it's equal to 0 and false otherwise. So how would you write that?
Would you say just like equals and then 0?
So equals 0, and this dude. Or you can go the long route and say, if it's equal to 0, return true, else return false. But you might as well just return what it was. All right, that makes sense? So this should give me a what? What should be the output of this program? False. Here's my false. And the output of this program should be true. Make sense? Not too difficult, right? I did give you the hard ones. That makes you feel better. But I think you'll find, hold on, I think you're going to find that these are far easier. I mean, we're solving a much harder problem. This is actually going to be far easier to solve than some of the other assignments you've had. They're much more straightforward. There's not really a trick to it. What you're really going to be working on in this assignment is understanding our variable environment and how do I add stuff to it, how do I extend it, and how do I get stuff out of it. Make sense? We've already written it, so I'm going to give you, I'll go ahead and, just so I don't have to pick and choose, I'm just going to copy the whole screen of code so you have my exact starting point, because up at the very top here is where I have our implementation of our variable environment, and then we have some jazz in the middle. Okay, so just ignore the jazz. All right, questions, comments, concerns, bribes. I will see everybody on Friday. And as always a threat of a quiz.
The Bible assignment's supposed to be.
Yeah, Bible assignment's up.